first, let's look at 10 to the third power. Exponents. What's 10 to the third power mean? Yes, sir. That would be 10 times 3.
Oh, 10 times 10 times 10.
Right, so not 10 plus 10, which would be 30, but 10 times 10 times 10. So how much is 10 times 10? And then times another 10. Yes, ma'am.
10 times 10 is 100, and 10 times 100 is 1,000.
Excellent, 1,000. But here's the shortcut trick. Oops, that's an ugly, ugly zero. I'm going to try to fix that. The shortcut trick is you don't even have to think about it that much if you know the shortcut trick. So look at your exponent. What do you have 3 of in your final result? Yes, ma'am?
3 zeros.
You have 3 zeros. The 10 to the third power is a 1 followed by 3 zeros. So there's a little bit of a shortcut trick. So determine the exponent of a positive power of 10. You need to count the number of zeros. Or if you go the other way, you're trying to tack on that many zeros. So for this first example here, 10 to the fourth, it's going to be 1 followed by 4 zeros. Don't try to verbalize it until you've then put your comma in to make it a properly written out number. So who can tell me what 10 to the fourth is equal to using the shortcut? Yes, sir?
10,000.
10,000. Boy, that's not making very nice zeros today, and I really need to make good zeros. So 10,000. Now the next one is asking us to go the other way, because it's not written as an exponent. So how would you write 100 as 10 to a certain exponent? Yes, ma'am?
10 to the second power.
10 to the second power. So you count up, I've got 2 zeros, so 10 to the second power. If it's 10 to the first power, how do we write that? 10. Any number to the first power is itself, but this is just there to prove that this shortcut trick even works in a situation like this. It's a 1 followed by 1 zero, because the exponent was 1. What about the number 1? We'd write that as 10 to the what power?
To the first power.
It has 1 zero? How many zeros does it have?
0.
So it's 10 to the 0 power. Because remember, any number to the 0 power equals 1. Because ultimately it's the number divided by itself. So any number to the 0 power equals 1, but this shortcut trick will work for that too.
It's like 10 degrees.
Don't get too confused with that. But really what we're going to ultimately use this trick for is figuring out how to move the decimal if I'm multiplying something times a power of 10. So 8.17 times 1,000 could also be written as 8.17 times 10 to the what power?
Third power.
To the third power. So even if it's written as 8.17 times 1,000, we could think of it as doing times 10, then times another 10, then times another 10. So the shortcut trick, our decimal digits rather, our digits will shift over to a bigger place value and a bigger place value and a bigger place value. But the shortcut trick is to move the decimal point itself. So times 10, times another 10, times another 10. So what ends up happening is we have to put a placekeeper 0 here, and it becomes 8170, which we read as 8,170. The comma is optional for a 4-digit number. So you could put the comma in there, but it's not required. So the shortcut trick when we're multiplying by a power of 10, or in this case, we'll call it a positive power of 10, not the decimal type of power of 10, you need to move the decimal point, the exponent numbers amount of places to the, I always mess up left and right, so if I go the wrong way, I realize, wait, it's supposed to become a bigger number, and I move it the other way. But if you're good with remembering rules and that sort of thing, it moves to the right. You're going to end up using this in science as well when you do your metric conversions.
What's that?
So what you don't want to do is write the number down again with the decimal point in it, and then swoop your decimal point and call it a day. If you're going to use this swooping technique, use it on the original pre-printed thing if you can, or at the very least rewrite the number after the decimal has moved to its new location. Mr. Schneer has gotten, someone will say it's 1,231 centimeters, but the decimal point's still in between the 2 and the 3 as well. So rewrite it with the decimal point in its new location. So for this first example, 12.31 times 10 to the second, I have to move it 2 times to the right, and it becomes 1,231. So you have to rewrite it with the decimal moved to its new location. You don't want it in its old location as well as in its new location. We've seen that happen sometimes. For the next one, 9.1 times 10,000. How many zeros are in 10,000? Yes, sir? 4 zeros are in 10,000, right? 1, 2, 3, 4. That means I take my decimal and I move it 4 places over. 1, 2, 3, 4. I need 3 placekeeper zeros. So the first move to the right gets me past the 1, but then I still need 1, 2, 3 more after that. So I end up with 91000, which I put my comma in between the 1 and the 0 to make it 91,000. For me personally, when I'm like checking over my work, I look at the ones digit number, which used to be a 9, and I go 9 times 10,000 would be 90,000. Yep, that 9 now means 90,000. And that first one, the 2, was in the ones place. 2 times 100 would be 200. Yep, that 2 is now in the hundreds place. So I kind of look at my ones digit number and just double check that it went in the right place and all the other digits sort of tagged along for the ride. The next one, 5.27 times 10. How many zeros are in 10? Yes, sir? Just 1. So I'm only going to move my decimal 1 place over. So take your decimal point, swoop it over, and what's my new answer going to be for 5.27 times 10? Yes, ma'am? 52.7. For the next one, 11.15 times 10 to the 0. That means I'm going to take my decimal and I'm going to move it 0 places to the right. So what's my result going to be? Sir?
11 and 15.
I'm going to still have 11 and 1500ths. So multiplying by 10 to the 0 doesn't move the decimal, you get the same result. But if you think about it, we said 10 to the 0 equals 1. Any number times 1 equals itself. So that should hopefully make sense too. What about 25 times 10 to the 3rd power? Some people get so into the moving the decimal point trick that they get this problem and go, wait, there's no decimal point. So when we were adding and subtracting decimals, we said if there's no decimal point, where would you put your decimal point?
Nowhere.
Well, if there's no decimal point in 25, but you needed there to be one.
Well, you keep moving it backwards.
Well, we're going to move it, but we don't even have a decimal point to move yet. So where would there be a decimal point in 25 to still have it be worth 25?
25.0.
25 and then a decimal point afterwards. You don't even need the point 0, but if we're adding and subtracting, usually we tack on extra zeros. So the decimal point is after the whole number. Then you can move it 1, 2, 3 times. That's the moving part that she was talking about. And so that means I'm going to tack on 1, 2, 3 zeros. So when I'm given a whole number, you go back to that tacking on zeros trick that you used to do. So 25,000 means we would have 25,000. So that's the shortcut trick for multiplying by positive powers of 10. Does everyone have that filled out? Tonight's homework, you're going to use this strategy to hopefully get that whole front side done with just the 15 minutes. Now we're going to look at division though. So the back side on tonight's homework is division. If we're going to do 15.7 divided by 10,000, it could also be written as 15.7 divided by 10 to the what power? 10,000 we said would be 10 to the what power? Yes, sir? 10 to the 4th power. So it could be written in either format. And that means we're going to divide by 10, another 10, another 10, and another 10, 4 times. Which with the decimal point means we can move it over 1, 2, 3, 4 times. But because it needs to be moved over further than the amount of digits I have, I need these placekeeper zeros. So it ultimately becomes 0.00157. But you know I just like having that extra zero in front just to make it clear where that decimal point was. But really, I would give it to you even if you had 0.00157. Because it moved over, divide by 10, 100, 1,000, 10,000. To double check your work, you can think about how far it moved over. To think about the ones digit. The ones digit used to be a 5. Now I expect my 5 to be in the 10,000th place. Tenths, hundredths, thousandths, 10,000th place. Now my 5 is in the 10,000th place. So everything's shifted appropriately. So the shortcut trick here. To divide by a power of 10, you need to move the decimal point, the exponent number's amount of places, or the number of zeros amount of places, to the left. Again, if I go the wrong way, I go wait. It's supposed to become a smaller number. 1,000th of the size, or a 10th of the size. So if I accidentally move it the wrong direction, I go, nope, it's supposed to be smaller from dividing by a power of 10. So for the first example down here, 8.7 divided by 100. How many zeros are in 100? Yes, sir? 2. 2 zeros in 100. That means I have to move my decimal point 2 places to the left. What's going to be the result of dividing by 100, or moving the decimal 2 places to the left? What should I end up with? Nope, I want to move it to the left this time. So swoop, swoop, over there. So if I put the decimal point here, I need a placekeeper 0, and then the 8, and then the 7. So can you read off what that should look like? So if I have a decimal point here, a placekeeper 0, and then the 8, and then the 7. Read that to me.
So the 0.087.
And again, to double check that it worked, I look at my ones digit, used to be an 8. I want it to be in the hundredths place now because I divided by 100. Tenths, hundredths, perfect. All my digits shifted over the way I needed them to. 103.1 divided by 10. How many zeros are in 10? Sir? 1. So that means I only need to shift my decimal point 1 place to the left. Or my digits all shifted 1 place smaller down the place value chart. So shift your decimal point 1 place to the left, and what should you get? Yes, sir?
10, 30, 100.
So 10.31 or 10 and 31 hundredths. Yep. So we're going to either read it casually, 10.31, or we're going to try to formalize it with 10 and 31 hundredths, the word form. For the next one, 2.01 divided by 10 to the first. So because it has an exponent, that's telling us how many to go. But it's to the first, which means I'm only moving it 1 place to the left. Who can tell me what that would look like? If I shift my decimal point 1 place to the left, or my digits shift down to make it 1/10 the size? 0.201. And I would begrudgingly accept that. I would like it a little bit better if I had that 0 in the front to make it clear, but I would take either one. So 0.201 or 0.201. So again, because the digits, or the decimal shifted over to here, so the digits could shift down the place value chart. What about 7.4 divided by 1? What you thinking on that one?
I'm thinking that you shift.
How many zeros are in 1?
0.
So you shift it in 0 amount of places, and what do you get?
7.4.
You end up with 7.4. So don't let this shortcut fool you into thinking the decimal's always going somewhere, because any number divided by 1 is still that same number. Same thing here. What about 4 divided by 1,000? How many zeros are in 1,000? How many zeros are in 1,000? 3. So you take your implied decimal that's after the 4 and shift it 3 places to the left. Swoop, 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 3 places. Which means I need 2 placekeeper zeros after the decimal point. My decimal point's here, 2 placekeeper zeros, then the 4. So who can tell me what I get as a result of 4 divided by 1,000? Yes, ma'am? 0.004. And again, my ones digit should be in the thousandths place now. Tenths, hundredths, thousandths, 4 thousandths. And then the last shortcut to consider is the one that ties into today's opener. That 0.1 is the same as 1/10, so it's the same as dividing by 10. In this particular case, 11.05 times 0.01 would be the same as 11.05 times 1/100th. So taking 100th of 11.05 would be the same as dividing by 100. So swoop, swoop, 0.1105. So this one, you're not going to see on tonight's homework, but I have 2 decimal places. So it moves my decimal point over 2 places to get it over there, because I'm dividing by 10, dividing by 100th when I want to take 100th of an amount. So to multiply by a decimal power of 10, which is really a negative power of 10. I figured calling it the decimal power of 10 may make it a little more visual for you. The 0.01 or 0.00001, that sort of thing. You need to move the decimal point, the decimal power of 10's number of decimal places. So you don't count up the 0, you count up how many decimal places there are. And again, it's going to make it smaller. I'm going to find 100th of the size, or something like that. So to the left. So if I had 65 times 0.1, 0.1 is the same as 1/10. So I want to find a 10th of 65. So who thinks they know what we would get if we found a 10th of 65? We got 1 decimal place here. We want to shift our decimal point 1 place over. Yes, sir?
6.5.
We'd end up with 6.5. For the next one, I know I personally have to touch and count them to figure out how many decimal places I have. 590.7 times 0.0001. So how many decimal places are in 0.0001? So decimal places mean how many digits after the decimal point, to the right of the decimal point. There's actually this one, this one, this one, and this one. All of these are decimal places because they're digits after the decimal point. This, here, 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 and here. So how many? 4. So if you count up the decimal places, it tells you how far over you need to move it. 1, 2, 3, 4, which means I still need a placekeeper 0 to make it work out. And it means my smart board is not behaving again. So 1, 2, 3, 4, the placekeeper 0 over there. This one will become 0.05907. The rest of the digits just fall in line with it. How many decimal places are in this very last example here? How many decimal places? 3. 1, 2, 3. So take your decimal point and move it over to the left 3 times. And what should we get?
0.00888.
So 1 swoop, and then 2 more placekeeper zeros to make the 3 decimal places that I need to move over. So 0.00888.